Okay guys, let's begin our discussion over the JEE Advanced Pattern Exercise for Probability. First question says there is a determinant which is chosen at random from the set of all determinants of order 2 with elements 0 or 1 only. So this is very important to understand that the determinant is 2 cross 2 and all these are coming from this set. Fine. The probability of the determinant chosen is non-zero. So first of all, what is the value of this determinant? AD minus BC. Now over here, if you understand, if A, B, C, D each is coming from this set, that means A can assume 2 values, B can assume 2 values, 0 or 1, C can assume 2 and D can assume 2. So this place can be filled in 2 ways, this in 2, this in 2, this in 2. So all these 4 places, one after the other, can be filled in 2 into 2 into 2 into 2, that is 2 to the power 4, which is 16 ways. So total number of determinants that you are going to get is 16, right? Out of them, how many will be non-zero? Now I want AD minus BC to come out to be non-zero, and you also know that A, B, C, D, each of them can either be 0 or 1, right? Now over here, what all are the cases of this particular number to be coming? Now because this is either 0 or 1, 0 or 1, 0 or 1, 0 or 1, AD minus BC will either be 0 or 1 or minus 1. I want determinant to be non-zero, that means I want the case of 1 and minus 1 to occur, I don't want the case of 0 to occur. And when can that happen? I can get determinant equal to 1 when AD is 1 and BC is 0. AD equals 1 can happen in only one way, A is 1 and D is 1. But BC is 0 can happen in 3 ways, when B is 0, C is 1, or B is 1, C is 0, or B is 0, C is 0. So there are basically 3 determinants which are going to give you the non-zero value 1. There are 3 of them. You put A1, D1, B0, C1, this is one determinant. A1, D1, B1, C0, second determinant. A1, D1, B0, C0, third determinant. And all these are going to give you the value 1, which is non-zero. Similarly, minus 1 if you want as the value of the determinant, because you want non-zero values basically. This can only come when AD minus BC is minus 1, which means AD is 0 and BC is 1. Now BC equals 1 can happen in only one way, when B is 1 and C is 1. But AD equals 0 can again happen in 3 ways, A1, D0, A0, D1, A0, D0. So again there are 3 determinants to give you the value minus 1, which is non-zero. So there are 6 determinants out of the total 16 determinants to give you the non-zero value 1 or minus 1, and therefore probability comes out to be 6 by 16, which is 3 by 8. Clear? And therefore your answer is option number B, that is 3 by 8. Clear? Now I have the next question, which is saying that a letter is taken at random from the letters of the word statistics and another letter is taken at random from the letters of the word assistant. What is the probability that they are same letters? So when I talk about statistics and assistant, what are the common letters? What are the common letters in the letters of the word statistics and assistant? You can see there is S common, there is A common, there is I common, and there is T common. S, T, A and I. Probability that you are getting the letter A in both the withdrawals. So in the first withdrawal, getting a letter A is from the letters of the word statistics. There are 10 letters in here. Getting A means 1. There is just one A, so 1 by 10 is the probability of getting A from the letters of the word statistics. And again you are withdrawing a letter here from this word basically, and there are 9 letters over here, and you can get A in 2 ways. So 2 by 9 And therefore, getting A in both the withdrawals is happening in 2 by 90 ways. Similarly, probability of getting T. Now, T over here you can see is 1, 2. 2 T's are there, so 2 by 10. And from the letters of the word assistant, there is 1, 2. And over here there are 3 T's. So, this is 3 by 10. And here there are 2 T's, so this is 2 by 9, which is 5 by 90. Fine. Then probability of getting S. Let's see how many S's do we have. So, here you have 1, 2, 3 S's, so 3 by 10. And here how many S's you have? 1, 2, 3, yes, so 3 by 9. So, this is 9 by 90. And then you have probability of getting I. How many I's are there? So, over here there is 1, 2 I's, and over here there is only 1 I. So, 2 by 10 into 1 by 9, which is 2 by 90. Fine. So, over here you can see, first of all we talked about A. How many A's are there? Let's just verify. How many A's can you see? 1. There is only 1 A, so you had 1 by 10. And how many A's you had over here? You had 1, 2, 2 by 9, so you had 2 by 90. After that you went to search for, so A happened, then you went to search for T. T's are 1, 2, 3 T's, and over here there are 2 T's. So, 3 T's and 2 T's, this is 6 by 90. And then you chose S and then you chose I. So, what is the probability of getting common letters in both the withdrawals? Either you can get both A's or you can get both T's, or you can get both S's, or you can get both I's. That's what we do. So, you have 6 plus 2, 8, 8 and 9, 17, 17 and 2 is 19. So, 19 by 90 is the required probability, which is option number C. Clear? Moving on to the next question, we have 6 distinct letters or numbers are selected from the first 150 natural numbers. Now, just stop over here. If you have 150 natural numbers with you, 6 distinct letters can be chosen from 150 available numbers in 150C 6 ways. That is the total number of ways of selecting 6 letters from the available 150 natural numbers. The probability that all the 6 numbers are divisible by both 3 and 5. The fact that the number should be divisible by both 3 and 5 can only happen if the number is divisible by 15. So, how many natural numbers from 1 to 150 are divisible by 15? Only those are the numbers which are divisible by both 3 and 5. From 1 to 150 there are 15, 30, 45, 60, 90 and so on till 150. There are 10 numbers in total from 1 to 150 natural numbers which are divisible by 15 and hence they are divisible by both 3 and 5. So, favorable is 10C6 because there are only 10 numbers from 1 to 150 which are divisible by 15 and hence are divisible by both 3 and 5. Out of them only 6 I want, so 10C6 is favorable, 150C6 is total. So, this is what is the probability, which is not this, not this, not this, and hence none of these is your answer. Fine. Next question says what? Let's see. A natural number x is chosen at random from the first 100 natural numbers. That means your sample space basically is consisting of 100 members in all. The probability that x minus 20 into x minus 40 upon x minus 30 is negative is what? Now, if I talk about this expression x minus 20 into x minus 40 upon x minus 30, I can alternatively write it as x minus 30 you multiply with and you divide with. Fine. So, this is my event E. I can say this is my event E. I have just multiplied and divided by x minus 30. Now, this will be less than 0 only when, because you know denominator is always greater than or equal to 0, so only when x minus 20 into x minus 30 into x minus 40 is less than 0. Because denominator is always non-negative, so when the numerator is negative, only then can this fraction be negative. For what values of x will this be negative? Of course, for x ranging from 0 to 20 or x ranging from 30 to 40. When x is going to come from this interval or this interval, I am going to get this being satisfied. How many natural numbers from 1 to 100 are basically coming in this category? This is 1, 2, 3 up till 19, and in here are 31, 32, 33 up till 39. Right? These are the numbers for which this expression is going to come out to be less than 0. And they are basically 28 in number. So out of 100 natural numbers, there are 28 natural numbers in total for which this expression is less than 0, and therefore probability is 28 upon 100, which is 7 by 25. Clear? Next question we have, if A, B, C are 3 events such that probability of A is 3 by 4, probability of A intersection B intersection C dash is given to you as 1 by 3, A dash intersection B intersection C dash is 1 by 3, then B intersection C's probability is what? So this is given to us, what is it? Probability of B intersection C dash. Okay, so B intersection C dash, if I talk about, how can I write this as? B intersection C dash, this can be written as probability of A union A dash, this is my universal set, intersection B intersection C dash. I can write this as A intersection B intersection C dash union A dash intersection B intersection C dash. Both these are independent events, so I can write this as probability of A intersection B intersection C dash plus probability of A dash intersection B intersection C dash. This is given as 1 by 3, this is given as 1 by 3, so you get 2 by 3 as the probability. And now I want to talk about probability of B intersection C. So probability of B intersection C dash is probability of B minus probability of B intersection C. So probability of B intersection C is probability of B minus probability of B intersection C dash. Probability of B is given as 3 by 4. So you have 3 by 4 minus probability of B intersection C dash, which is 2 by 3. Right? So you get 9 minus 8 by 12, which is 1 by 12. So probability of B intersection C is coming out to be 1 by 12. Next question we have, A and B are 2 events, probability of A and probability of B is given to us, and then we need to talk about the options being correct or not. First is probability of A union B is greater than or equal to 2 by 3. Probability of A union B is greater than or equal to max of probability of A and probability of B. Probability of A is this, probability of B is this, max is 2 by 3. So yes, this is correct, that probability of A union B is greater than or equal to 2 by 3. Next, let's talk about probability of A intersection B. Probability of A intersection B is probability of A plus probability of B minus probability of A union B. I want to talk about this being less than or greater than or equal to something. Now you know probability of A union B is less than or equal to 1. So minus of probability of A union B is greater than or equal to minus 1. This is equal to probability of A plus probability of B minus 1. So this becomes what? You basically get, this is 6, this is 3 plus 4, that is 7 by 6 minus 1, which is 1 by 6. So probability of A intersection B is yes greater than or equal to 1 by 6. What about it being less than or equal to? For this, we should be aware of this relationship between A intersection B, A and B, that probability of A intersection B is less than or equal to minimum of probability of A, probability of B. Minimum of them is 1 by 2, so yes, it is less than equal to 1 by 2, so this is also correct. Then probability of A intersection B dash is less than equal to. So probability of A intersection B dash is probability of A minus probability of A intersection B. Now probability of A intersection B is greater than equal to 1 by 6. So it is negative of it is less than equal to minus 1 by 6. This is less than equal to minus 1 by 6. Right? So you basically get, this is 3 minus 1, that is 2 by 6, which is 1 by 3. So you are getting probability of A intersection B dash is less than equal to 1 by 3. What about A dash intersection B? Okay, so probability of A dash intersection B is probability of B minus probability of A intersection B. Probability of B is 2 by 3. Probability of A intersection B is greater than equal to 1 by 6, so minus of it is less than equal to minus 1 by 6. Right, so you get 4 minus 1, that is 3 by 6, which is 1 by 2. Moreover, probability of A dash intersection B, probability of A intersection B is less than equal to 1 by 2. Right, probability of A intersection B is less than equal to 1 by 2. So minus of it is greater than equal to minus 1 by 2. What is this? 4 minus 3, that is 1 by 6. So this is greater than equal to 1 by 6 and less than equal to 1 by 2. Yes, so all the 4 options are correct. Clear? Moving on to the next question, we have that a student is appearing for 3 tests, and I am saying that if he passes in 1 and 2 or 1 and 3, then I am going to say he is successful. Probability of him being successful is given as 1 by 2. Then which among them is correct? So suppose I define 3 events A, B, C as passes in first test, passes in second test, and passes in third test. Okay, then probability that he is successful is, what is the probability? It is probability of the event that A happens and B happens but C does not happen, or A happens and B does not happen and C happens, or A happens and B happens and C happens. This is the probability of being successful, which is given as 1 by 2. Now you know that these are all independent events, so I can just shove this union off and I can write this as plus probability of this plus probability of this. Now these are again what independent events? This is probability of A into probability of B into probability of C dash. Probability of A is this, probability of B is this, probability of C dash is 1 minus 1 by 2, which is 1 by 2, plus probability of A, probability of B, probability of C, plus probability of A, probability of B, probability of C. This is what you are given. 1 by 2, if you take out common, you have PQ plus P minus PQ plus PQ. Right, what is this? PQ, half is coming out common, plus P minus PQ plus PQ equals half. Right, so you basically have what? That PQ plus 1 equals 1. And when I talk about this equation, P times Q plus 1 equals 1, every value of P and Q is actually going to satisfy this. So here if you can see this, each one of them is going to satisfy. In fact, there are infinitely many values of P and Q which are going to satisfy that equation, and therefore A, B, C, D, all 4 are the correct options. So we did nothing, we just wrote the probabilities P into Q into half, then P into 1 minus Q into half, then P into Q into half. So we took out half common, we were left with PQ plus P minus PQ plus PQ. So minus PQ plus PQ got cancelled, P common, Q plus 1 equals 1. Clear? Next question is what? Let's see. Consider the system of equations. This is a homogeneous system of equations in two variables. Probability that the system has unique solution, no solution, exactly two solutions and a solution. Now if your concepts are clear, you know that any homogeneous system of equations always has a trivial solution. If you put x equals 0, y equals 0, you get this system getting satisfied. So the very probability that it has no solution, this probability is 0. There are 0 chances that there is no solution, because of course there is always one solution present when x is 0 and y is 0. So no solution will be mapped to 0, that is B will be mapped to R. Two solutions, no, again this is 0, because homogeneous system of equation can either have one unique solution or infinitely many solutions. It is never going to have exactly two solutions. So C also gets mapped to R. A solution, it is definitely going to have at least one solution, that is for sure, so the probability is 1. And I told you that one solution which is x0, y0. What is the probability that it has unique solution? A unique solution can only occur when this is not equal to 0. And over here again the same scenario is occurring, that A, B, C, D is coming from this set. This determinant can be non-zero, that means this can be non-zero when this is equal to 1 or minus 1. This can be 1 in 3 cases we just saw, and this can be also minus 1 in 3 cases. When A is 1, D is 1 and B is 0, C is 0, A is 1, D is 1, B is 0, C is 1, A is 1, D is 1, B is 1, C is 0. These are the 3 determinants which are going to give you 1 as the value. And when are you going to get minus 1? When B is 1, C is 1, A is 0, D is 0. When B is 1, C is 1, A is 1, D is 0. And when B is 1, C is 1, A is 0, D is 1. These are 3 cases which are going to give you minus 1 as the determinant. No other non-zero number can come as the value of the determinant, which is acquiring all the 4 entries coming from 0 and 1. And therefore there are 6 possible cases, 6 possible chances are there, favorable outcomes are there for giving you a unique solution out of the available 2 to the power 4 solutions of the value of this determinant, because this can be filled in 2 ways. So 2 to the power 4, which is 16 possible values you have. So probability of getting a unique solution is actually 6 by 16, the same answer, that is 3 by 8. Clear? So A gets mapped to basically Q. Moving to the next, we have, let A, B, C be 3 mutually independent events. What do you think? A and B union C are independent, A and B intersection C are independent. So let's see A and B union C. How can you interpret this? See, this is probability of A intersection B union A intersection C. This can be written as probability of A intersection B, you know the formula, plus probability of A intersection C minus probability of A intersection B intersection C. A and B are independent, so this is probability of A into probability of B plus probability of A into probability of C minus probability of A, probability of B, probability of C. Fine. Probability of A can be coming out common. You are left with probability of B plus probability of C minus probability of B into probability of C. But probability of B into probability of C, this is equal to probability of B intersection C. So inside what you are left with is just probability of B union C. So probability of A intersection B union C is probability of A into probability of B union C. So yes, these 2 events are definitely independent. What about A intersection B intersection C's probability? This is very easy. I know A, B, C are mutually independent, so I can write this as probability of A, probability of B, probability of C, which can be written as probability of A into probability of B intersection C. Fine. So probability of A intersection B intersection C is probability of A into probability of B intersection C. So even these 2 are independent. Clear? Next we have A and B are two events such that probability of A is given to you as 0.3. A union B's probability is given to you. If A and B are independent events, then 7 times probability of B is what? Let's see. Now probability of A union B is probability of A plus probability of B minus probability of A intersection B. Probability of A union B is 0.8. Probability of A is 0.3. Probability of B you don't know. Probability of A intersection B is probability of A into probability of B because A and B are independent. 0.8 minus 0.3 gives you 0.5. Probability of B comes out common. 1 minus probability of A. 1 minus 0.3, which is 0.7. So you get 0.5 upon 0.7 is probability of B. What is this? 5 upon 10. And this is 10 upon 7. So you just get 5 upon 7. You want the probability of 7 times probability of B. 7 times probability of B is 7 times 5 upon 7, which eventually gives you the integer 5 as the answer. Clear? That's how we apply all the concepts to tackle the questions. So practice them nicely. That's it from my side. Thank you.